A survey shows that 2/3 of the students at Keller Elementary School play a sport after school. The survey also shows that 2/6 of the students participate in choir. Draw models represent these two fractions. So when comparing fractions in 3rd grade, they have to know that when the denominators are the same, they just look at the numerators. So for example, if you were comparing 2/6 with 4/6, the denominators are the same. So all you need to do is look at the numerators, and you can easily see that 2 is less than 4, so 2/6 is less than 4/6. Now, that's rule number 1 when comparing fractions. Rule number 2 is what do you do when the denominators are different? And that's like this example. So you're comparing 2/3 with 2/6 in that example. So when you start your fraction unit, you teach your students all the different models that you have when you're looking at fractions. So all the different models that they will encounter, we're learning about fractions. Number lines, fraction circles, drawings, polygons, and I have a little anchor chart for that I can send you. And the students glue that in their journals, and it's an anchor chart also, and they refer to that throughout the year. And they're responsible for using one of those models to solve the problem. So for example, this question, I wouldn't use fraction circles because it's hard for students to make them equal. Because something that the kids have to know is that when comparing fractions, you have to have the same size whole. That's really important for them to know. And dividing that fraction up, partitioning that fraction up equally. So I start with the rectangle, okay, and then we split it here. So I'm going to represent 2/3 here and 2/6 here. So I'm going to partition the top into 3 equal parts because that's my denominator. Then the bottom will be cut or partitioned into 6ths. And I always show my kids, if you have 6ths or 8ths or halves, always start in the middle. It's much easier if you begin with cutting it in half and then splitting the rest. So I'm going to have two lines here to make 3 parts, and then 2 lines here to make 3 more parts for a total of 6. Then you can go into shading. Here's 2/3. So we have 2/3, and then we have 2/6. And part of that rule is them knowing, and we just drilled this and we repeated it. We used sentence stems, and the kids knew the bigger the denominator, the smaller the fractional piece. The bigger the denominator, the smaller the piece. Because in the fraction world, because they just automatically think 6 is bigger, so it's a bigger fraction. But in the fraction world, they have to realize that the bigger the denominator, the smaller the piece, because you are partitioning it more. You're sharing it with more people. So I give the example, the real life connection of a pizza or a pie. If you're cutting it in one pizza, if you're cutting it in half, let's say, and the other pizza, you're cutting it into 4ths, which pizza would you rather have, the half or the 4th? And of course, they'll say the half. So this just helps them realize that the more you cut it, the smaller the pieces will get. So that's just an example of that. And then I tie in unit fractions, and I make them tell me, what does this piece, or what does each piece represent? 1/6 plus 2/6 plus 3/6, and on and on. And then the same thing. This is 1/3, 2/3, 3/3. Always tying in those skills, even as you keep going within the unit, and making them go back to all those different models. And like I said, I can send that to you. And then also, something else that they struggle with is with equivalent fractions or fractions in general. When they're having to compare fractions, they'll ask them, these are both a half, yes, but do they represent the same half or the same size whole? And the answer is no, because if you look at this half, it's way bigger than this half. So they have to know that these are not equivalent fractions, even though they both represent a half, but it's not the half of the same size whole. In order to compare fractions, your wholes must be congruent, the same shape, the same size. So that's also the same if you're comparing a circle with a square. You cannot do that because the wholes are not congruent.